This video shows how to use synthetic division to divide polynomials. We have been using long division to divide polynomials, and long division is a method that will work for any polynomial, but it can be a little cumbersome. You have to write down all those x's and keep track of lots and lots of things. Synthetic division is a little bit simpler to use once you see how it works. Unfortunately, it only works on dividing linear polynomials, so it's not quite as useful, but if you like it, you may decide to use it where you can because, like I said, for some people, it just seems to be an easier, quicker process. So synthetic division is only going to work if we're dividing by something like x plus 1 or x minus 2, something like that, where you're dividing by a linear factor. It's not going to work if you try to divide something like x squared plus 1 or x squared plus 2x minus 1, something like that. For these, you'd have to use long division. So you would need long division. And if you're looking for a little review or some practice on how to do long division, you may want to check out some of the earlier videos. But this video, we're going to be using synthetic division, and probably the best way to see it is just to watch me do a couple of problems. I'm going to be using problems from page 122 in your book. If you want to follow along there and go back and see what they're doing. And they're actually going to use synthetic division to factor a polynomial, but I'll do that in some later videos. I'm just going to actually do the synthetic division process in this video. All right, so I am going to take this polynomial, 3x cubed minus 4x squared minus 28x minus 16, and I'm going to divide that polynomial by x plus 2. And of course, you know how to divide that long division. This piece here goes outside the box. This piece here goes inside the box. And we're going to do something similar to that using synthetic division, but in synthetic division, we are only going to use the coefficients. So just the 3, the negative 4, the negative 28, and the negative 16. And we're going to put those coefficients inside the box, but this box is going to be an upside down box. So it looks a little weird, I know right now, but I promise you it's not that bad. So here's 3, negative 4, oops, writing is in a funny place. There we go, negative 4, negative 28, and negative 16. And just like long division, I want to make sure that I have something in every decimal place, or every exponent's place. So I've got a cubic, a square, a linear term, and a constant. I don't have to have any placeholders here. And then this is going to look a little bit weird. I'm going to divide the x plus 2. I have to divide by this whole polynomial by x plus 2. And this is the number that's going to go on the outside. I'm going to leave the x, out of it for right now. But what goes on the outside is not 2, but the opposite of 2. So this is actually going to be written as divide by negative 2. And the reason for that is when you know how when you set a factor equal to 0 and figure out where the zeros of something are. So if I said, oh yes, I've got these factors, I don't know, I have maybe a bunch of factors, x plus 2, and maybe there's some other ones, x plus 1, and I don't know, x minus 3, right? So pretend this is another problem. And I have all of these here, these wonderful factors, and I probably have them equal to 0, and I want to know where the zeros are, and I had to set each factor equal to 0 to find them out. Remember doing that? So x plus 2 equals 0, x plus 1 equals 0, x minus 3 equals 0, and then I would solve each of these equations and get x equals negative 2, x equals negative 1, and x equals 3. So I'd end up with all these numbers that were actually the opposite of what I started off with. So the numbers after you solve the equation are actually the zeros. The numbers inside the parentheses being added or subtracted from x are the factors. So when those numbers are part of the factors, they're opposite signs from what they are when they are zeros. So when we're using synthetic division, we're going to use the sign of that number when it's a 0. So we just want to make sure that it's an opposite sign. And if it doesn't make sense to you why it would be an opposite sign for right now, don't worry about that piece. Just for right now, just make yourself a little note that you're going to write the opposite sign. And probably after you've done a couple of these, it's going to make a little bit more sense why it is the opposite sign. So just kind of take it on faith for right now. We're going to write it as the opposite sign. So it'll be a -2 that we're dividing by, not a +2. Okay, so back to the synthetic division problem here. I now have it all written out, and I am going to bring down my first factor. So I'm going to actually bring down that 3 and write it down. And then I am going to multiply. So I'm going to multiply 3 times 2. I'm going to multiply 3 times -2 actually, and I will get a -6. And I'll write that inside the box. So -6. And then I'm going to add them together. So -4 plus 6 is -10. Then I'm going to repeat that process. -10 times -2 is +20. Write that inside the box. And add those numbers together. -28 plus 20 is -8. So I'm going to multiply again. So just like long division, we have this repeat process. -8 times -2 is a +16. It's +16, and then add them together. -16 plus 16 is 0. And when I've run out of factors, then I'm done. And in long division, we ended up with a remainder sometimes. And if we had a remainder of 0, then we knew that our polynomial that we were dividing by was a factor. And here, this piece right here, this last column, will give us our remainder. And in this case, I've got a remainder of 0. All right, my only last step is to actually write my answer. And when I was doing the problem, I took out all the x's. Well, now I'm going to put the x's back in. And when I do that, I'll remember that I was dividing, right? So let me just write down my factors here. I was dividing, and that meant I went down a power of x. So if I've started off with an x cubed up here, right, my answer is actually going to be an x squared when I'm done. So here's, whoops, this becomes x squared, and -10, that's going to be in my x spot. And then -8 is just my number. That 0 is my remainder, which means I don't actually have a remainder. And there's my answer. All right, I'm going to stop this video so it doesn't take so long for it to load on your computers. But the next couple of videos, I'm going to do some examples, just do a bunch of problems where I am dividing using synthetic division. Right now, you may want to look at back this up and look at just the problem a little bit, or you may want to go ahead and look at the next set of videos. See you soon.